Hello and welcome to Problem Bank 7B. Number one, here in 7B we start talking about centripetal acceleration. Again, acceleration is just a change in velocity. Velocity being a vector, meaning it has both magnitude and direction. So centripetal acceleration is not necessarily due to a change in its speed or angular velocity, but a change in but it's constant change in direction as an object moves about a circular path. So number one, what is the centripetal acceleration of a skater moving with a tangential speed of 2 meters per second in a circular path with a radius of 2 meters? We are given v sub t equals to 2 meters per second. We are given a radius of 2 meters. Unknown is our centripetal acceleration, which we'll denote a sub c. Our equation is going to be one of two centripetal acceleration equations, and because we were giving a tangential speed or a linear velocity, we will use the equation a sub c, or the centripetal acceleration, center seeking acceleration, is equal to v sub t squared divided by the radius. Substituting everything in, we get a sub c is equal to 2 squared over 2. Solving that out, be 4 over 2, which is just 2 meters per second squared. Number 3. The distance from the center of a Ferris wheel to a passenger seat is 12 meters. So we'll call that our radius. What centripetal acceleration does a passenger experience when the wheel's angular velocity is 0.50 radians per second? So we were given an angular velocity. Omega is equal to 0.5 radians per second. Our unknown is our centripetal acceleration again. The equation we'll use for that is a sub c, or our centripetal acceleration, is equal to our radius times omega, or our angular velocity squared. Substituting everything in, 12 times 0.5 squared. 0.5 squared is going to be 0.25, or 1/4. 1/4 of 12 is going to be 3. So 3.0 meters per second squared is our centripetal acceleration. Number 5, a ventilation fan has blades 0.25 meters long. So we are given that our radius of our fan blades is 0.25 meters, rotating at 20 RPM. Careful thing here is that R is going to stand for revolutions, and that is revolutions per minute. So we start with 20 revolutions per minute. And we're going to want to change that to radians per minute. So what we do there is we multiply by 1, and we know that 1 revolution is the same as 2 pi radians. And we know that 1 minute is the same as 60 seconds. So multiplying all that out, 2 pi over 3 It gives us 2.09. Now what we should have left is radians per second, which we do. And the question is what is the centrifugal acceleration of a point on the outer tip of a blade? So our unknown is the centrifugal acceleration. And again, we will use the equation centrifugal acceleration is equal to our radius times our angular velocity squared. Substituting everything in, we see that 0.25 is our radius. We're going to times that by omega, which is 2.09 squared. That is radians per second. Our solution to that is A sub c is equal to 2.09 squared equals 4.36 times 0.25. Is equal to 1.09 meters per second squared. And number 7, a point on the rim of a 0.20 meter radius rotating wheel has a centrifugal acceleration of 4.0 meters per second squared. So we are given a radius. We're given a centrifugal acceleration. What is the angular velocity of a point 0.10 meters from the center of the wheel? So our unknown is our angular velocity, which is omega. Our equation is going to be our angular acceleration is equal to r times omega squared. Now, we know that because if we look at a clock, and we have a second hand on that clock, we know that it's going to take 60 seconds to get around that clock. So if we were a point right here, we were a point here on the outside, it would take us 60 seconds to get around. That would be our angular velocity. If we had another point somewhere in the middle of that second hand, it still would take us 60 seconds to get around the clock both times. So no matter if we are standing 0.1 meters from the center of the wheel or 0.2 meters from the center of the wheel, our angular velocity will be the same. So as we plug in what we know, we see that we have 4.0 meters per second squared is equal to R, which is 0.20 meters. We're going to times that by omega squared, divided by 0.2, divided by 0.2. 4 divided by 0.2 is going to be 20 radians per second squared. And then as we take the square root of that, we see that omega is equal to 4.5 radians per second. Number 9. A turntable spins with an angular speed of 3.5 radians per second. So given is our omega again. A quarter placed on the turntable has a centripetal acceleration of 2.0 meters per second. Squared. How far is the quarter from the center of the turntable? So how far is the quarter from the center of the turntable? So we'll try to draw our turntable right here. I believe a turntable is another way to say record player. And this turntable has an angular velocity of 3.5 radians per second. So it's asking us where on this turntable from the center is a quarter placed. So that will be our R. Okay, so our unknown is our radius. Our equation is going to be A sub c is equal to our radius times omega squared, substituting in 2.0 meters per second squared, divided by 3.5 radians per second squared, equal to our radius. And calculating that out, 2 divided by 3.5 squared is equal to 1.6 or 0.16 meters. So our radius is equal to 0.16 meters. All right, number 11. A roller coaster has a loop-the-loop in which the centripetal acceleration on the cars and passengers just equals 9.81 meters per second squared. Now again, 9.81 should ring a bell. That is the quantity of acceleration near Earth's surface. The tangential speed of the roller coaster cars is 15.7 meters per second, was the radius of the loop-the-loop. So we are given v sub t is equal to 15.7 meters per second. We are given centripetal acceleration at 9.81 meters per second squared. Our unknown is the radius. Our equation is going to be A sub c is equal to v sub t squared over r. Substituting everything in, we know that A sub c is going to be equal to 15.7 squared divided by 9.81. Our solution is going to be 15.7 squared, 246, divided by 9.81, or our centripetal acceleration is equal to 25.1 meters. And that is it for tonight. Thank you.